We've learned how to graph inequalities, and we've learned how to graph systems of equations, and now we're going to learn how to graph systems of inequalities. So, graphing an inequality in two variables is when you graph a line. The line is either solid or dotted, depending on if you have the equal to line on your greater than or less than symbol. And then you shade above or below the line. If it's greater than, you shade above the line. If it's less than, you shade below the line. A system of inequalities is exactly the same, except now we're going to graph two of them. And the solution is the spot where the shading overlaps. In a system of equations, the solution is where the two equations intersect. In a system of inequalities, the solution is where the shading intersects. So step one is graph the two inequalities. So these are going to be pretty simple to graph because they're both already in slope-intercept form. So let's start with this first guy here. I'm going to graph this one in blue. It is y is greater than negative 2x plus 1. So pretty straightforward. It's got a y-intercept of 1, and it has a slope of negative 2, which, of course, if I wanted to write as a fraction to get rise over run, would be negative 2 over 1. So let's go to our graph here. And I'm going to put my y-intercept at 1. And then a slope of negative 2 means down 2 and over 1. Now, when I connect these points to get my line, I need to ask myself, will I be connecting these with a dotted line or a dashed line? Or will I be using a solid line? And to answer that question, I look at the symbol. This is greater than, not greater than or equal to. If it's got the equal to line, it's solid. But because this is a just greater than line, I'm going to do a dashed or a dotted line just like this. Oops, that last one is a little crooked. There we go. Okay, so here's my dashed line. And now the last thing I do with a inequality that I'm graphing is I decide where to shade it. Am I going to shade above the line, which would be to the right, or am I going to shade below the line, which would be to the left? And in this case, since it's greater than, I'm going to shade above the line. So I'm going to shade everything in this section here. So let's color that in. There we go. Perfect. Okay, so now I'm going to do the exact same thing with the second inequality, and let's go ahead and do red for this one. Now this one has a y-intercept of 3, and the slope here, since there is no visible coefficient in front of x, the slope is just 1, which as a fraction is 1 over 1. So on our graph, we're going to start with 3, and then we go up 1 and over 1. And we need to decide if we will be connecting this with a dotted line or a solid line. And since this is less than or equal to, since it does have the equal to line underneath, we will be using a solid line. So let's go ahead and connect our 2 points here and using a solid line to connect them. There we go. And now the last thing we have to decide is, will we be shading above or below this line? Its y is less than shades below the line. So we're going to go ahead and shade everything below our line, which is going to be this part here. And as I'm shading, you should see a part of this graph that ended up being shaded twice. And that part that was shaded twice is the solution. And in fact, I'm going to go over that with what do you get if you mix red and blue? Is that purple? I'm not good at art. I think it's purple. Red plus blue is purple. So this section right in here, that section, let's be like Harold and get our purple crayon here. This section right here is the solution. The solution is the part that was shaded twice. So I'm going to shade that really dark. There we go. That section right there, that's the solution to our system of inequalities, the part that was shaded 2 times. What it means is this system of inequalities has a bunch of answers, an infinite number of answers. Any point that is in that shaded section, any point that appears in there is a solution to this system. So for example, if I just pick any random point, let's pick this point right here. And I shaded so well that I can't actually see that point. So let's just assume that point is 5, 0. 5, 0 is an answer to this system. This point up here looks like maybe it's, what was that, like 3.54, we'll say. I shaded so well I can't see the points, but 3.54, also a solution to this system. Any point that is inside that shaded area is a solution to this system of inequality. So it has infinitely many solutions. Any point inside the shaded area is a solution to this system of inequalities.